Okay, we're working on a air handler here that has a squeaky bearing, so we went through and put some oil in it and eliminated the squeak. This particular air handler, I've got one on either side. There's one on the left and a right, and they're twinned together. And there's actually 4 squirrel cages. This is the left unit, this is the right unit. There's actually 2 motors. Typical unit has got a Carrier Bryant motor here. There's a bearing that's very difficult to get to in the back, and this one in the front you can get to if you take a zoom spout and you go in there, one of these zoom spouts like this. Or you can use a big stick. I can go in there and get at the shaft. It's back in there. So what happens on these, it's real easy to lubricate the one that's on the outer here. And what I do is I go ahead and mark on the side of the box here in pencil when I last did it. And if you do it over here in Sharpie, the Sharpie tends to kind of disappear with time. So something I learned from my dad, you want to go ahead and just use caveman technology. Go ahead and use a pencil. That's going to be on there forever. Proper way to do it is to go ahead and pull the blowers out. And this particular unit, they've got slides. You have to undo this complete box on here. What you do is take a picture of it with a digital camera, your phone, whatever, and record where the wirings are. Is an easy way to do it in case you goof something up. This one here on the right, because it's a twinned unit, it's got another control here, but it has what they call a twinning unit, and it's got a big rat's nest of stuff. And so what I've done over the years is I've pulled this one out before, and the whole blower out, and got it out in the sidewalk and cleaned it all off and oiled up both bearings properly. This one is a booger bear to do. I mean, it's like you've got to go ahead and you got so many darn wires here. You got to go ahead and make sure you don't muff something up. It's real easy to do because you've got wires here that can have a fatigue failure. You put it back and then you'll think it's connected, but it's actually broken inside. So I kind of have a healthy respect for not screwing around with that unless I have to. But I'm going to probably end up doing that at the end of the cooling season this fall, maybe late in the fall or maybe in January I'm going to do it because I don't really need the heater that much. Anyways, on here over the time I've always gone ahead and lubricated this front bearing because it's easy to do. Sometimes that's the one that is squealing and it goes away. But if it's one here in the back, I've got a special gizmo here where I've taken a piece of flag that's plastic, a big hook like this. I've got to fish this back in here and around the back and try to get to that bearing. And that's a real a mess to do because you got to get into here and try to go to the back. You can't get it from this back side there because the plate here that supports the wheels in the way. So if you take it outside, you can go ahead and undo this thing and pull it off, take the whole shebang apart. But it's a lot involved here because you got all this big rat's nest of wires. So what I did here, just experimentally, I went ahead and bored a hole through here. It's about 3.5 inches from this one edge, and I got a piece of plastic, got this back in there, and I got behind there to oil that. Also got the zoom spout in there. I got this to free up to where I can spin this by hand here, and then it'll coast down it'll go a lot longer than it used to. And then I've cleaned off the connection here with alcohol, and I've got some aluminum tape. It doesn't have anything flammable on it. I cover this hole up here. And then what I'm going to do later, I've got some time, I'm going to go ahead and put a piece of sheet metal, some screws on. Now over here on the ducts, I've got some building material screws to hold a Butler building together. And that's for the testo probe to measure carbon monoxide. combustion analysis. So what I did is I just had some of these big screws in our junk box and bored the hole, and then you stick those back in there instead of using tape. That seems to work pretty well. But something like this where you've got a big mess of wires on here, it's almost like I need to go through and take this whole shebang and mount it below this. The only thing that's on here that's functional is it's got this one temperature gizmo here. And I could actually mount this horizontally in here below the blowers. That's probably what I'm going to end up doing, is I'm going to take this whole thing, and if I have to lengthen a few wires, so be it. I've got a lot of slack over here. But mount the thing down below this. So if you ever mount a unit, you got to think about the maintenance if you own it yourself, because somebody can, you don't really see that many units twinned together, but you get this big ass box in here that gets in the way to pull the blowers out. Just makes the task real easy to get it screwed up, in the sense that get a lot of the 24 gauge wires that can get busted. So clean all these off. You can go through and take a picture with the phone and everything like that. And on this particular unit, this is a modern control here from ICM. The older ones here seem to be more robust for, I guess, lightning or power surges on it, because there's nothing really, there's only like one or two little chips on it. This has got, seems to be a little bit more to where I've replaced more of these new ones than the old ones. But the problem with the old ones is they tend to sometimes stick. So every now and then, after you have like the power will go off here every few months or something, I'll come in and the fan will be going on. If you tap this real hard with a wrench, it'll go off. So just because the unit's off here, you don't want to go putting your hand in here, try to get oil in there, because if this relay somehow got tapped on, boom, the blower is going to turn on. At least for this one, it's only going to turn this blower on, but you just want to go ahead and make sure everything is off so you don't lose a finger or something like that. This is an older unit. This is from 1985, so we've been nursing it along. Been really a robust unit. In fact, these have got the original motors from 1985, and here it is 2019. So what is that, 34 years. It's got the same run caps too. So if somebody wants to come in and say, oh, we've got to replace the run caps, I'm not going to replace them. It's been in there for 34 years still working. It's kind of a dumb thing to do. Probably a new one's going to go ahead and go quicker. Now, this one here I took off. You see, I put on the little cheat sheet. White, black, red. And there's the positions on there. That's actually for the speed of the blower. This particular carrier, you can change these around because it uses a different speed for cooling and heating and stuff like that. And so I mark it on there with a pencil. You gotta be careful if you start marking something on there and then you go through and take some cleaner to clean it up. You don't want to remove it off. So you may want to take a picture of this stuff with your phone too. And you can see here I put Mobile 1 in 2006. And we put some Mobile 1 in 1997. So this one went from 1997 to 2016 without being oil. And here I pulled the whole shebang out, June of 2016. Both bearings, Mobile 1 10W30. Then I did the outside one last May, and then I just did this one in July, just the outside bearing because it's hard to get at. This one was the one making the noise, so I went ahead and bored the hole, which is kind of not the best way to do it. I'm not really proud of that. In fact, I screwed up just a couple other holes there. But this type of tape holds real well, so I'm not too worried about it. And if it is, I'll go ahead and make a plate to cover that. But this is on the list to contemplate pulling this whole sucker out of there. If you pay somebody to do this, they'll come in and they don't want to do it because it's too much of a risk to get boogered up. In fact, I couldn't even find this thing documented in the web. I actually bought a new old stock one just to get the manual from a place in Indianapolis that sells surplus stuff. Yeah, it's pretty complex how it's wired up. That's about it. And there's the hole that I'm covering up. And I put a little flap here on this so I already know which one it is. I cleaned all that off with rubbing alcohol to get the grease off. It'll stick better. And I'll come back and check this, see if that's actually going to hold. What is this stuff? Some natural tape. All aluminum. And I want to cover this up because if this is not covered up, it's not going through the filters. Got an hour meter over here. This has got 1,588 hours since this is hooked up across the contactor for the compressors outside. So see how many hours this guy runs. Both of them cost me about $1 an hour to run. Okay, on this Carrier unit, the CG of the two rotors is roughly about right in here. And so the one bearing is right here at the plane of the case just about. And so what happens is the force on this bearing is just about all the downward force here. And this guy that's the inward one is just supporting a smaller force to prevent this from rotating. If the CG was right over this bearing, then this guy would have no force on it up and down. And so just some rough numbers I measured. This is roughly 1 inch. From here to here is roughly 6 inches. Just wanted to show some seat of pants numbers here. So if I just assume both of them weighed 30 pounds, I'm not sure what it is, but it's in that ballpark. It's not 10 and it's not 50. It's say 30 for both of them combined. You have a 1 inch, one bearing here that's 1 inch away. One's 5 inches. So what you do is you take this force and this force has to equal 30. So you go and say that B plus is equal to A plus 30. These are going down. This is pushing up. So A plus 30 is equal to B. Then what you do is you have to make sure there's no moments on it. It's balanced in the sense that if you did a moment like torque around this point, the distance between this force to here, this force to here is equal. So you take 30 times 6, it has to equal to this force times 5. So you've got 30 times 6 is 180, divide that by 5, you find B is equal to 36. And you drop this back into here and you've got, this is 36, that's a 30, that's going to be 6. So roughly you've got on here 6 pounds on this bearing, 36 on this one, and this is the 30 down that I assumed for the weight of both rotors on the CG. Now if you move this force to be right along with this one, of course this would go to 0. I was just doing this because at first see the pants I thought there had to be a higher force on here because that's why the one's going bad, but after looking at it, the CG is very close to this one bearing, which means this has got to have very little up and down force on it. But over the years, it's a booger bear to get to this one. So this is the one that gets oiled, the one that's of course easy to do. Stick a zoom spout in here, touch this. This zoom spout, I put some Mobil 1 in years ago. And gingerly, you can see the shaft on this one right here. It's easy to get at. This booger here, when I went through the hole in the side, I'm actually going through the squirrel cage. So I'm just frogging around trying to aim this. Now, the danger is you could go ahead and stick it through a hole in the motor and get this in the windings, which isn't good. When I've got this apart, I might be able to bore a hole on here and maybe put one on the other side, a small one to make sure, if there's any balance, get it close to the center, and then get the zoom spout in here. That's kind of what I did on the other one. I believe I went through and I've snuck something around here, and I turned this around by hand in the parking lot, and all of a sudden, lo and behold, it just went super easy. Spin around, you can sit there and count how many seconds it takes to go down. The one I quote fixed is just really a kludge in the sense that it still doesn't spin down as quick, as slowly as the one on the left. So I'm kind of on borrowed time. So this whole method is really going to get me by, but it's not the best way to do it. And then this thing here, I've done this before. It's really difficult because I have to put oil on the end of this tip and then sneak it back behind here and then kind of feel around to see if I can get the end of it. Then you twist this around, and at one point you'll notice all of a sudden it'll go like mad, but you got a lot of oil going all over the place, which isn't really good for the motor or anything. So proper ways to pull these out, and it's not always done because you get the situation here where you got just a rat's nest of wires and you find out it's not really being done. The instructions on the motor say, from 1985, say to put 5 to 20 drops in of 20 weight non-detergent oil every 5 years or something like that. But that's on the list to do, just to go ahead and pull it out. I'll have no air conditioning, so I got to do it on when I'm closed down for the weekend or something. But I prefer to do it in a time that it's neutral. I don't need any air conditioning, which here is going to probably be in October, November.